Hi viewers, I welcome you all for this video lecture series on separating concern between handling HTTP request and executing business logic in REST API. Before that, I introduce myself. I'm Shankar. I'm working as assistant professor in the Department of Computer Science and Engineering. And let's go to the video and discuss the topic. REST is a type of web service, and HTTP is a form of transfer protocol. Let it be any web service. The transfer protocol can be HTTP or JMS. REST can communicate over XML or JSON, but the protocol for transferring the data would be in the form of HTTP. Roles for business logic in API development. Business logic defines how data is processed, manipulated, and transferred in response to user interactions. In API development, it determines what data is collected from users, how it's stored, and the process it undergoes before being delivered or updated. Business logic is the engine that powers the functionality of APIs. And let's see few examples for business logic. If a person has high salary but no experience, then they might be overqualified for the job. Suppose if a person has experience but no salary, then they might be underqualified for the job. If a person has both high salary and experience, then they might be qualified for a job. So here, the business logic is the set of rules that governs data creation and changes specific to industry and business. Business logic plays a crucial role in digital transformation, determining how technology integrates with business infrastructure. Understanding our data structure and its role in front-end application is fundamental in implementing any transformation initiative. Scaling business logic with APIs involves horizontal scaling, which means load balancing or microservices, and vertical scaling, which means rate limiting or optimized code. Next, API generation automates API creation, simplifying development and allowing developers to focus on refining core business logic, ultimately enhancing application functionality. And next, scaling business logic with API. As business grow and experience increased user demands, the need to scale their infrastructure to handle higher loads and data processing requirements becomes paramount. Scaling business logic effectively is a critical aspect of ensuring that applications remain responsive and reliable. Let's see what is horizontal scaling. Horizontal scaling involves adding more resources such as server or containers to distribute the workload evenly across multiple instances. So it consists of some key factors. First one is load balancing. Load balancing implement an API gateway or load balancer can evenly distribute incoming requests across multiple instances of your application. This ensures that no single server becomes a bottleneck and helps maintain consistent response times. Next one is microservice architecture. It organizes your business logic into microservices, each encapsulating a specific function or features. API acts as the communication layer between these microservices, allowing you to scale individual components independently based on their usage patterns. And next, elastic scaling. It utilizes cloud-based infrastructure that allows you to dynamically add or remove instances based on traffic fluctuations. Cloud providers offer services like AWS autoscaling or Kubernetes autoscaling that can automatically adjust the number of API server in response to demand. And finally, caching. It implements caching mechanism at the API level to reduce the load on backend systems. Cached responses can be served quickly, reducing the need to recompute or retrieve data for every request. Next one is vertical scaling. Vertical scaling involves increasing the capacity of a single server or instance to handle more significant workloads. And it has some key limits. First one is API rate limiting. Implementing rate limiting on API endpoints to control the number of requests on a single client can make within a specific time frame. This prevents individual clients from overwhelming the server and allows for fair resource allocation. And next, optimize code and algorithms. Continuously optimize your business logic code and algorithms to make the most efficient use of available resources. Fine-tuning the performance of your API endpoints can significantly enhance vertical scalability. The next one is vertical scaling tools. If using virtual machines or dedicated servers, consider using tools and technologies that enables you to increase CPU, RAM, or other resources as needed. API endpoint can be fine-tuned to take advantage of the added capacity. The next one is database scaling. When business logic heavily relies on database operations, vertical scaling of the database can also be essential. API can help manage connections to the database and distribute queries effectively. Next, content delivery networks. Offload static content and assets to CDNs, it reducing the load on your API servers, and it can serve cached content from the edge locations closer to the user to improve the response times. And next, REST API enables you to develop all kinds of web applications having all possible CRUD operations, which means create, retrieve, update, and delete operations. These resources are business entities such as users, customer, and products. Instead of using verbs like create or post or delete, use nouns in endpoints leverage like HTTP methods called get, post, put, delete to perform operations on resources. And for operating a business basic create, retrieve, update, delete operation on entity user, we can use the following endpoints methods instead of creating user, delete user. So here I have given only two it's simple examples. One is get and post. So in this example, the endpoint name is user. So the endpoint can mention like example.com/user. So here we are using the method called get, which operates to get details of all the users. Next one, I have given post example. So in this post, the endpoint is example.com/user. The method we have used post, which helps you to create a new user. Next, let's see the REST API's error handling. To avoid any confusion and unnecessary complexity errors should be gracefully handled with the proper HTTP written codes such as 401, 403, and 500 to indicate the kind of error that has occurred, along with a message stating the reason this error could have occurred. This allow user to better understand what went wrong with the request. And next, separation of concerns. Separation of concerns is a design principle that divides a software program into segments. Each subsection attempts to address a distinct issue, a group of details that have impact on the program code. This concept essentially refers to an architecture pattern in which program logic is separated from the program content and presentation. This makes the project easier to maintain and less prone to repetitions. It also seamless line changes and team collaboration. The API folder comprise subfolders for controllers, middlewares, routes, and repositories, which are mostly used to handle the tasks like data transmission, request processing, and validation. The services folder contains reusable business logic that handle tasks such as data processing, implementing unique business logic, calling the database, etc. The next services. Services handle things like data manipulation, database calls, and other business logic. Separating app services from controllers is a separation of concern technique. The service layer contains business related logic and nothing related to the HTTP layer. This technique allows for easier test writing, refactoring, and thinner controllers. Services implement our application logic and communicate with the database via data access layer before returning the necessary response to the controller. We made a simple authentication service file that contains our sign in and sign up logics. Our next controllers. Controllers receives request, make a call to the required service, and then communicate with the database via the data access layer. Then sending the results back to the services, which then sends the results back to the controller, and the controller delivers the results to the client. We will create a file called index.js in our controller folder that will contain our sign in and sign up controllers. These controllers use the request and response object in the asynchronization handler.js file to send requests to various services. And next, routes. Routes simply define how our application should respond to the HTTP request from clients. It is the portion of our program code related to HTTP hooks. Middleware may or may not protect these routes. Routes' primary function is to handle requests as they arrive. I thank you all for watching this lecture series. I thank you once again.